This is S1, Chapter 1, Lesson 8, the last lesson of perms and coms. So the binomial theorem, so we're just kind of fully expanding Pascal's triangle. We got all that pattern stuff down to use the binomial theorem. So just a review of that. We understood that you have the first row is your exponent of 0, and your second row is exponent of 1, etc. And then we kind of combined it with essentially what's happening in terms of combinations. The combinations, they represent the coefficient of the term, and the coefficients are these values here. So they do have these same patterns all the time. What can change it, though, is that we're not always dealing with simple variables, x plus y. As we get more advanced at this, and in this lesson, we're going to have like 2x plus 3. So if I say 2x plus 3, what do we treat as our y? The 3. And so the 3 is going to be cubed. And so that's going to give you a value that will change your coefficient, okay, just in terms of just the mathematics of it. All right, and that's just multiplying. That's just multiplying. Okay, don't freak out yet. Okay, so so exploring it. So just coming through, x plus y to the 6th. We just plugged in. Essentially, these up here are 1, 6, 15, 20, 15, 6, 1. They're right here in front. And all I was just saying when some of you guys looked like you were confused already is that this number doesn't always have to be a variable. That could actually be a value. So if I just said y was 3, then the only thing that happens is I just go 3 times 6 and write 18. That's the only thing that changes. Okay, I'm just telling you, don't think it's always a variable. Don't always be looking for y. Okay. All right. So let's go and do the one down here for 7. Or wait, what are we doing? Oh no, we're doing. Oh yeah, we're doing the combination pattern. Excuse me. Okay. So now we're gonna write it in terms of combinations. So using the list up there, which I think is the easiest to, because it's really cohesive in terms of it matches the exponent. Okay, it's like I told you earlier. So we're doing exponent 6. So that means we start with 6c0 x6 plus 6c1 x5y, 6c0, 6c1, 6c2, 6c3 x3y3, 6c4 x2y4, 6c5 x1, you can write x1, you don't have to, y5, and then lastly 6c6 y6. Anybody want to take a shot at just kind of looking at that and seeing if you notice a pattern with the x and the y's compared to the combinations? Do you notice a pattern with that at all? Yeah, correct. Yep. The y is always matching this number. So this is 0. That's why there's no y there. This is a 1. That's a y1. This is a 2, y2, 3, 3, etc. Correct? So the y, the second term, has the exponent. We call that your choose number, the NCR. So, okay, NCR. Can anybody see the relationship of the x exponent? How is that created? Someone besides Cam, and then we'll get somebody to Cam if we have to. Correct. N minus r. Okay, so n minus r. So look, what's 6 minus 0? 6. 6 minus 1. 6 minus 2. 4. This is how you can be comfortable, because I know, look at that. That looks insane. Tons of C's, tons of numbers, a lot going on, tons of variables. I get it. But when you organize the pattern, it doesn't matter. You could do, I could ask you to do the 20th row, and you should be able to do it. Right? It's just a pattern, it's to be continuous. Okay? So you're right. The y, or the second term's exponent, is the r. Okay? The x, or the first term's exponent, is n minus r. Okay? Any questions? Okay? All right, so that's what they're kind of doing. They're setting you up here. They're setting you up, getting used to that. And so they said the binomial theorem, that's essentially what they're telling you here, is the pattern of it. But here is what you're going to be using on the diploma. We'll talk about what k plus 1 means. Okay? But that's essentially the form. So nck equals n minus k. They just changed the k to k instead of an r. Okay? N minus k and then k. Does anybody know why it says t of k plus 1? Why does it say that? Yeah, the term. Okay, and why does it have to be plus 1 for the term? Why does it move you over 1? Not the row. We're talking about terms now. So we're talking about the stuff in the rows. The amount of terms is always one more than the row. Remember? There's one more. The other reason why is because what's the first NC I do? It's NC 0, so it counts 0, so we have to do term plus 1. So we get an extra term because we're counting 0, okay? You'll see what that means in a second, but I'll continue to show you. Okay? All right, so let's look at this one here. These are the type of questions you can expect. Determine the fifth term of that binomial with the binomial theorem. What's the fifth term? So if we're talking about the fifth term, what we want is, how do I get the fifth term? What do I want k to be if I want t of 5? 4 plus 1, right? 4. I want 5. Okay. I want term 5, so I want term of 4 plus 1. That's how I have to use this formula. Okay, so if you want term 6, I'm going to use 5 for my k. Okay, so here we go. That means that k is 4. What is n? 8. That's all you need. We can do everything now. Okay, n is 8 because that's the exponent. Okay, they want the fifth term, so 4 plus 1 is 5, so k is 4. So we are ready to use this formula. So NCK, 8 choose 4, times x to the 8 minus 4, x to the 4, times y to the 4. Okay, if you're confused about the 8C4 thing, I will do this one time for you. This thing done out would be this. I won't do it all the way. I'll just do it till I need to. Okay. So, they said the fifth term, right? 1, 2, 3, 4, 5. That's why the pattern moves you over 1, because we start with 8C0. That's what the k plus 1 is doing. It's just sliding you over. Okay? So if you want the fifth term, we want to put in k plus 1 for the form. Okay? And then if you do 8C4, if you actually get that number, 8C4 is 70. So this actual term would be 70x4, y4. That is the fifth term within that binomial theorem when it's expanded. So then and why are we doing this? Because we're not going to FOIL out 8 binomials. That's insane, right? We're using this pattern to our advantage to help us. Okay? So why don't you try the middle term of a plus b to the 10th? So I'll say is, if it's the 10th exponent, how many terms are there? 11. So then what number signifies the middle? The 6th. You have 5 this way. You have 5 this way. So the 6th term is the one you want. I just gave you the head start. Now see if you can find that. Okay, I'll pause the video. All right, so let's take a look here. So middle term, so I said we're going for the 6th. So if we're going for the 6th, we want to do t of 5 plus 1 essentially. So 5 is my k. And then we know my n is 10. So we're saying that 10c5, 10 minus 5. So another thing I'll tell you that's kind of, whoops, yeah, a to the 5th is correct. Got my eraser too big here. I always just get in the habit of doing brackets here in case it's negative. Okay, if you don't like that, that's fine. But in the beginning, I like putting brackets so that I don't mess up my signs. If they tell you the middle term, guys, the middle terms, they have your two terms have the same exponent. 5, 5. That's not a coincidence either. If they're asking for the middle, their exponents are going to match because that's the symmetry part. It's sitting in the middle. Okay, and I'll show you something in a second. But what's 10c5? 252. So 252, A5, B5 is the middle term of that sequence or series of terms. Yes. Yeah, they'll do stuff where you have to solve for A or B. That's the part that I told you you're probably not going to like. Okay? They do a couple of tricky things, actually. There's one that's pretty hard with the exponents we're going to do today. All right, so good. Challenge. Love it. I'll take this off. All right, back at it. So use the binomial theorem to write the expansion of x plus y to the 7th. So I just want you to expand this whole thing. So this is what I'm telling you. It's just a pattern now. So I'm just going to say, okay, 7c0, x to the 7th. You can write y to the 0 if you want for a second, but don't do that very often. 7c1. Yep. I'm just writing the whole thing out. This wants all the terms. See, I'm just 7c0. I'm just starting right from the start.
What's that thing you did for the first one, right?
Correct, yeah. Plus 7c2, which is x 5, y2. I'm going to have to wrap it around here. x4, y3, 7c4, x3, y4, 7c5. Where are we at? x2, y5, plus 7c6, two more, x1, y6, and 7c7, just a y7. Okay. So we just wrote out the entire expansion for that one just for practice. Okay. Okay, any questions? Okay, so like I said, I have to say, like, and you guys are being fair, you're worried about what's coming in terms of solving. You need to get the pattern locked in. If you don't have the pattern locked in, you're going to be lost before you start. Okay, so you need to get the pattern locked in terms of how it changes, where you're at. Getting that practice is more crucial than, you have to have that in order to be successful in solving. Okay, so let's go ahead and look at, see this question here. So the complex is more applied to more complex situations. So here's your first solving example. Susan will determine the fourth term of 2x minus 5 to the 6th. So now you can see I have numbers now. I'm not just variables. Okay. It says part of her work is shown. Complete her work to show the fourth term is negative 20,000 x cubed. So we're trying to prove that that's the fourth term. Okay. So she knows her x is 2x. She knows her y is negative 5. The k she wants is 3 because of 3 plus 1 is the fourth term, right? It wants a fourth term. That's where the k comes from, the term number. Okay? N is 6. That's what you're talking about. N is 6. That would be correct. The 7th row, there's 7 terms. Okay? So here's her work so far. So she applied this. So she did 3 plus 1. So 6c3, 2x to 6 minus 3, negative 5 to the is cubed. So you just plugged in the stuff. See? 2x. She plugged that in there. She knows that it's 6 minus 3. Don't be overwhelmed. It's just the pattern. Okay? Negative 5 to the 3, because that's the r. Okay? And then she's going to calculate. But what's important here is that 6c3 is 20. Okay? I have to, what's 6 minus 3? 3. What's 2 cubed? 8. 2 cubed, that's right. 2 cubes, 8. And then you have to cube the x. People forget this all the time. They just do the x. Make sure both things get cubed, right, by your distribution properties of the exponents. So the 2 gets cubed and the x gets cubed. Okay, that's probably the most common mistake I see when people solve these. And then negative 5 cubed is negative 125. It's odd. Nope, it's good. It's odd. Okay, and so then what you do is you simply go, see how this x cubes here? Well, that's just going to stay x cubed. So let's write x cubed. Only thing you have to do is that times that times that. 20 times 8 times negative 125. That's all you need to do. If there was another variable in this, then it would just, you can just write right next. If it's like y squared, you just put y squared next to the x. It's all a product. Negative 125. And that would be in front of the x squared. X cubed, which is the negative 2,000 or 20,000. That is the fourth term. That's the fourth term in the expansion. Okay. Couple things I want to show you guys. You know how like you can really see the symmetry of x and y? Well, there's not a y here, right? So how do you know you're in the right spot? Well, you know that the first term is going to have what for an x? Let's talk about just x. x6. And what's the second term going to have? Look, that's the fourth spot. We know that's how it's going to come down. So you can really make sure you're in the right location by the exponents. The exponents are really good triggers if you're in the right spot. Okay? Triggers, yeah. Aggressive. Okay? All right, so this one, determine the fifth term. So now we got two variables. So to your question, Isla, we got two variables now. Oh, Leah, sorry. Why did I say I keep saying Isla. Leah. Okay. Yeah, true. That's not why, though, actually. That's not why, but that's okay. Okay, determine the fifth term. Determine the fifth term. So we want the fifth term. I want t of 4 plus 1. So that means my k is 4, my n is 7, and my, see, the fifth term, I mean, that's all we need, actually. K, 7. Oh, you can write your x, you call it, is 3x. Your y is negative 2y. The negative does stay with it. That is important. So we're going to find the fifth term. This is only the four information you need. If you have these four, you can use the formula. You should be good to go. Okay. So that means that I'm doing, what's my combination going to be? 7c4. Good. What is my 3x going to have for an exponent? 3. 7 minus 4. And what's my negative 2y going to have? 4. And now we just simplify this. So 7c4 is 35. 3 cubes, 27. So we had 27x cubed here. Negative 2 to the fourth, that makes the negative go away because it's even. That's going to be 16y4. Now all you have to do is multiply these three numbers to get the coefficient. When you do that, you should get 15,120, then write x cubed y4 on the end. That is the fifth term. All right, any questions? All right, got three more to challenge you a little bit. We okay? Ish? All right, that's okay. Good yawn, good yawn. All right, let's check this one out. All right, so Alden has been asked to solve the following problem. One term the expansion of x squared plus a to the 8th is 114,688. Determine the numerical value of a if a has to be positive. Okay, Alden does not know how to proceed because he does not know which term he is looking for. Okay, his friend Griffin explains how to determine the value of k by showing the following work. So his friend Griffin says, well, x is x squared, y is a, k is k, we don't know k, and then n is 8. So I'll explain a little bit what's happening here, but I'm just going to cut to the chase a little bit. If we have an x4, how do you get an x4 from an x2? Let's just... Right. That means it's the square piece of the first. So what I'm saying is, if I know I'm going for an x4, how do I get an x4 from an x squared? By squaring it. So pretend this was just an x. If I told you how do you make that an x4, you'd say, well, you x to the fourth it. Well, if now there's a 2 there, we have to, how do we make that 4? It's timesing that by 2, because power to power means multiplication. Okay? So we know, why I'm telling that is that we know then, if that's 2, and this is a power of 8, what's the a to? 6. 6 plus 2 is your 8. So we know that every time we do this pattern, Janet, that these two exponents of x and y have to add up to the total. If I know I want an x4, and the only way I get an x4 is by squaring an x squared, that means that's a 2. My a has to be 6. Now we know that's the spot in the pattern I'm at. Right. I'm going to walk you through what they're talking about. They use exponents to show you, but I think it's a little bit more direct if you can just figure out what I'm trying to make the x be. Okay, I'm trying to make the x be an x4. How do I do that? I square that. Okay? Yep, and so we're not done yet. Like, yeah, so the front, you're right, the front is 8c6. 8c6. Okay, well, I mean, we said, look, just follow the pattern. That's k. It's nck. What's n? 8. I mean, you already had all the work to do that. Well, it's just like, I'm just showing you that we know this adds up to 8. No, just like this, you did the hard part, right, was my point. This adds up to 8. That's always k. So that's what that number is. N is what the exponent is, so you already have that one. So the 6 really isn't that big deal to get that. It's just that last exponent. Okay. Now, maybe that was more direct. I actually think you'll probably like that better than what they're doing, but I'll show you what they're doing still. Okay, so what they're doing here is they keep everything in general terms. They sub in the stuff that they know, so they don't know k the whole time, so they keep leaving the k's blank. Okay, and so what they do is, see how they have 16 minus 2k? So what they've done is, why is it 8 minus k? Where did that come from? Right, we have 8 minus k, right? That's what the exponent's supposed to be. So distribute the 2, that's where the 16 comes from. 16 and negative 2k. This distributed because that's what power to power is. Power to power is multiplication of exponents. And so 16 minus 2k, this is where they have to cheat. 16 minus 2k, that value should equal what? By what they're showing us up above. 4. 16 minus 2k should equal 4 because we expect our x to have an exponent of 4 because that's what they told us. The exponent on x is 4. Are we okay with that? Oh boy. All right, so minus 16, negative 2k, minus 12. 4 minus 16 is a negative 12. And then you see we get again, k is 6, which we got. The 4, because they told us this is where we're going. That's what the exponent. That's the number we expect to be on the x. So I'm setting this on the x equal to 4. Does that make sense? And so now we know what k is that way. And so once we get all that figured out, so again, if you liked just me kind of reasoning with it up here, or if you like solving the exponents here, both ways are mathematically fine. Now we're just going to finish it off. So it's 8c6 x to the, what did we say it was, the 4th. 16 minus 2k, what did we write on there actually? I wrote, yeah, it's this, but that's 4. And then it is a to the 6th. So where people get freaked out here is they're saying, well, wait, 4 plus 6 is 10. That doesn't work. Well, why is it different? Because it's x squared, right? We don't have just an x anymore. That's what's changed. Okay, so be okay with that. If you want to write it this way, just so you can see it better, that's still fine. You can write it that way if you'd like.
Why would they make y equal 6?
Yeah, I mean, variable is a variable. Like, yeah, it's not, that's what I'm saying. Don't get locked into y. That's really important. It's going to be a number. It could be another variable. Okay, it's not going to be y all the time. Okay, all right, so we kind of answered some of this stuff. So the term we are looking for contains x4, term the value of k, so we did that already. K was 6. Use the values of k to simplify, and we just did this as well. This part, so we did a and b already. Okay. Oh, they want us to actually multiply it out, though. So what is the actual values of doing that? So the values are, oh, that's what this is here. Oh, this one. Okay. We'll solve for a. We had this here. Let's write this here real quick. This was 28 x4 a6. Thanks. I almost wrote y because of Lizzie.
Sorry.
It's okay. I blamed you already. All right. There we go. Oh, my goodness. x4 a6. There we go. 28 x4 a6. Okay. So that says equate t of k plus 1 to this value and solve for a. So what they want us to do is they're saying that a is a number. Do you understand? A is a number. So we're going to set this equal to this. You're going to see how this makes things pretty easy, actually. So what do we want to do algebra-wise here to solve? right, take 28x4 off, and that's nice because it cancels the x's. So that's gone. That divided is 4,096. And now we sixth root. And you sixth root, you get the nice number of 4. It's plus or minus 4, but they told us a had to be positive, so we just write 4. Whenever you even root something, you have to consider the plus or minus, but they told us a was positive in the question. Okay, it's a little bit of solving. Bad news is that's not the hardest one. Okay. All right, let's do 6. I think you'll be okay with 6. Then we got 7's going to frustrate you. So get ready.
7 looks ugly.
Yep, 7's going to be a little tougher. All right, so it says determine the numerical coefficient of the term containing A7 in the expansion. So guys, like if it's A7, it's nice. I just have an A. So I know, like just right off the top of my head, 3 cubed negative A7. It has to be. That's the only way I'm going to get an A7. There's no square here, so I don't have that little hiccup we had last problem. Okay? Does any of you guys not like that? Is there questions with that? Why is it 3 and 7? 3 plus 7 is 10. Okay, there's no extra exponents to worry about, so we don't have to, it's going to add up to what it should. And so you still have your front is going to be 10C7, right? Okay, so a little more organized way of doing it. I know that's a little bit just kind of jumping the gun. My x value is 3 in the pattern. My y value is negative a. My, we don't know our k technically. And then our n is 10. Okay, but then we figure out our k is 7. I'll do the exponent way as well. If you don't like what I'm doing here, it's fine. So this is if you want to figure out the exponent way yourself. You would have 10ck. You'd have 3 to the 10 minus k, and you'd have negative a to the k. And so with it written that way, you know that that 7 has to be there. K has to be 7. That's as simple as it is for this one. They do go ahead and write this negative 1 out, and it's important to do that because this is the same thing. I'm right with the 7. And it's just so that you don't lose the sign, the negatives.
Where's that negative 1 coming from?
Just because of that minus sign in front of the A. It's just making sure you remember there's a negative sign that's being multiplied here. You can leave it in there too. It's fine. You don't have to.
So you can just do negative 2 instead?
Yeah. Right. In this case, we know it's going to end up what? Negative. As long as you recognize that, that's all. This is the way the book writes out in the notes to kind of make sure you remember, hey, don't forget your sign. Okay?
What's that initial
A. What's this? So this is,
formula, right?
yeah, so this is me kind of cutting to the chase because I know that A is 7. So I put a 7 on the A. And if that's 7, it has to be 3 on the 3. Right. Yep, exactly. 10 minus 7, yep. Okay? Because as soon as you recognize, guys, that A is 7, that's your K. And now you have everything you need to do the actual problem. Okay, so if we go ahead and do this here. So 10C7 gets us, what's 10C7? Is it, no. Somebody do 10C7 for me. I know 120. So 120 is 10C7. 3 cubed is 27. And then we know we're going to have a negative 1 because of that 7 on the negative. And so this is what you're going to multiply to get your coefficient. Negative 1, 27, and 120. When you multiply those, you're going to get negative 3240 A7. That is your term with an A7. Okay? All right, I'll pause the video here so we can take a breath. Okay. Yikes. So scary. So scary. Okay. So we have the expansion of 2x minus 1 over x squared to the 15th. It says determine the constant. 90% of this problem that people run into is they don't know what constant means. Can we tell me what constant means? Well, that is definition of constant, but yes. In terms of if you're listing terms, which thing's the constant? Cool, but what else? Be more descriptive. Doesn't have a variable. Constants don't have a variable. So you're trying to figure out what term will not have a variable. So we're trying to figure out when my x's go away. We're trying to figure out when my x's will go away. Now this is where it gets a little bit weird because y, see that's a -2 for an exponent. So there's going to be a point in this binomial, like when they products, where the exponents are completely going to cancel. All right, how can we do that? Okay, so let's just, what do we know? What is x? The x spot. 2x. What's the y spot? Sure, you can write -1 over x squared, or you can also call it -x to the -2. It's up to you. Well, it could help you later. You never know. But that's fine. You don't need it right now. And then what is, we don't know k. That's the whole point. And we do know n is 15. Okay, so what we're going to do is we're going to write t of k plus 1 out. This, you should be getting familiar with this, but it's going to be nck. You get this formula, by the way. It's on your sheet. You get x to the n minus k, and then you have your, I'm just writing in general terms, y to the k.
So could you technically put 2x there?
I'm going to replace them next, yes. Okay, so for this problem, we don't know k, so we do know, we're going to fill in everything we know. We know it's 15 ck. We know it's 2x, okay, to the n minus k, which we're going to write as 15 minus k. And then we know it is -1 over x squared to the k. It is helpful here because we only care about the variables. That negative sign's kind of like an ugly thing we don't want to worry about. So it is helpful here to separate that out, like I showed you in the previous problem. So 2x to the 15 minus k. I'm going to write this as a -1 to the k. It's -1 to the k. Okay, and then I'm going to write it as x to the -2k. Now the negative's gone. So I moved it up. The reason being, okay, I want to write like this, and then we're going to do the work here. I'm going to show you. I'll pause. I'll take questions. I know this is a lot. -1. See how it's a negative here? It's just me separating it from the x. See how the k hit it? It's just me writing it in two things. But the -1 is like kind of like pulling that off top. It's -1 over 1. So you don't have to write the over 1. Right, sure. If it was, yes, if it was a -2 over x squared, I'd do a -2. Because it's this, like right here, it's over a 1.
What if it was over like 5x?
Then 1/5. Sure. We're not going to do that though, but yeah. Okay, so then 2x, 15 minus k. And then, like I said, this -1 just hangs out. We really don't need that right now. I'm just going to write it over here, actually. And then what I'm going to do is, this is the crucial spot. What would this be right here if I wrote it with one exponent? What's the rule of the exponents of these two numbers? Multiply. Right, -2k. Now, I want to just open this up to you guys and see if we can do this. We want the variables to go away, correct? What do we want from these? Yeah, well, okay, good question. So let's just take a step back. They both have an x in there, right? They both have an x, right? Right, like terms? Yes, like what you're saying is fine. So actually, your like terms is correct, but I separated the -1. I do want to separate the 2 as well. We want to just push the 2 out as well. We want to deal with just the x's. This 2 is just sitting here, okay? Okay, I'll explain why I did that. Just 1 second. Okay, so essentially, terrible K is all the way around. Not getting any better. Okay, so the point of this, guys, right now is that we are trying to eliminate the variables. So I need to get the non-variable stuff kind of pushed off. this exponent hits both things. We know that, right? If you have 2x squared, it's going to be 2 squared x squared. Okay, so I'm just doing it with 15 minus x. So 15 minus x is on the 2, 15 minus x is on the x. This k here, we made it negative 2k. Okay, so it's negative 2k here. That negative 1 only had a k on it. It doesn't have the negative 2 because that's not part of it. Okay, that negative 2 comes from this. All right, so that's these steps here that I'm doing. You can just say isolating base x, base of x. Try and get base of x is isolated. Okay, now, it's okay if you're still a little lost. That's fine. There's another problem with this in your notes or your practice problems you can try. So if I told you you wanted to cancel something, when things cancel, what does that mean with their exponents? So when you cancel an x, yeah, you divide them, correct, but when you do that, what would their exponent be? So like if I said you have x squared over x squared, what's the rule for exponents? Minus. What's 2 minus 2? 0. So when you cancel stuff, it gets to be to a 0 power. Right? X to 0 is 1. That's why when those cancel, it's not 0, it's 1. That's the reason. Do you see what I'm saying about canceling? So I'm telling you is, we want this to equal to 0. Oh, not the 2. Bless it. I circled the wrong thing. It's these two, the x things. We want those to be 0. So see how it's 15 minus k plus a negative 2k equal to 0, and just solve for k. That'll tell you what your k is. If they're 0, guys, that means they cancel. If they're 0, that means they cancel. I know this is hard. So watch, minus k minus 2k, 15 minus 3k, minus a 15. Divide the negative 3. K is 5. Yeah. I put plus because the multiplication of exponents means you add them. Even though it's plus and negative, it's fine. I just write the plus so you know we're adding the exponents. Okay, so honestly, that was all the hard work because now we just plug it in. So getting them to cancel is the really difficult part with this problem. So if you're saying, well, wait, what are you talking about? Well, we're done. We have k now. We have everything to do this problem.
How do you know that's the step that you start?
What's that?
How do you know that's the step where you're like, okay, I can make this equal 0 now?
So since it tells us that we want a constant, that we know we want equal to 0. So your job, once you know you're going for a constant, is to get your stuff simplified so that your x's are alone with exponents, and these x's and their exponents have to cancel. Because the x has to go away in order for it to be a constant. Because if you still have an x, you don't have a constant. Okay? So let me plug it in, and you'll see how it cancels as well. But this means that we're going to have 15c5. I'm just plugging in k now. Okay? We can go to right here. You can go 2 to the 15, so 2 to the 10th. 15 minus 5? Yeah, what's up? I'm going to show you the part of the cancels. You're going to see why this makes sense in terms of when we plug it in. X to the 15 minus 5 is 10, right? And then what is negative 2 times 5? It's not a coincidence. Those cancel. And then negative 1 to the k, which is 5. So guys, look, this is the whole purpose. That canceled. All you have to do is multiply those things. And that's your answer. Your answer turns out to be negative 3075072. Okay, that is the constant in that pattern that you will get. Negative 10, yep. Negative 10, yep. Negative 10. So it's a negative 2k, so negative 2 times 5, because we got 5 for k. Because that's what we got for k. K is 5. Well, it's negative 2k. Put a fun.
Oh, we're filling in the k.
Yes, yes. Okay, yeah. Okay. Yeah, that's top in there.
So are we actually